Alright, should be making a video again. Yes, 0 points. Very marginal answer. Yeah. Probably there is. Eventually, someday, maybe. The truth will be respected, blah, blah, blah. And, yeah, they'll fix what's broken in their science, quote unquote. It's just really not science. This is really that obviously bad. So I guess we're just gonna play some of this Professor Lewin video again, and just go through some of the arguments that what they're saying doesn't make any sense. How they're saying it makes it even less sensible, and it's goes to the core of the function of the universe in terms of their statements and the contradictions in it even. I mean, it's on its face kind of silly to say, nature can finagle kinetic energy. Well, if it can finagle it, then it's not, it's not real if it can be finagled. But whatever. Probably will be some commercials in here, blah, 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 as usual. And, sorry about that, but that's the way he's decided to present his physics, is with a bunch of tacky, crappy advertisements on top of it. Why isn't that selecting properly? Don't know. Yeah, there's just no selecting window around that one. I can't resize it, which is really strange. Must be locked. Ah, that's why I can't. Yeah, okay. Now I can. Ah, alright. So that was easy. Alright. So, let's play some of this crap and we'll just go through it. I'll leave the captions on.
Afterwards, so this.
Okay, let me fix the volume a little bit. I need a little more anyway.
Must be m2 times v2 prime minus m1 times v1 prime.
So just kind of inverting it and just saying, look, it's the two things are going to have energy. They're going in opposite directions. So in a sense, if you were in a spaceship, a container, and you shot the two things, the container will get enough the same movement in both directions. So to some extent, you can say it starts off being with no influence, and it'll maintain no influence because it's symmetrical in how it's going to distribute its energy. And so saying something about the symmetry of explosions might make some sense, but to say there's zero momentum is, in my opinion, ludicrous, because obviously you have momentum going in both directions. Yes, they're opposite directions, but they're not unmomentum. One of them isn't called anti-momentum. You don't arbitrarily declare one of them anti-momentum. I mean, it's, there's nothing about their individual properties that say they don't have momentum. The two objects leaving will have momentum, real energy in the universe. And so it's just kind of silly to say the universe doesn't have any more energy in it, when clearly it does have more visible energy. And that's all this is really a conversation about, right? Is the fact that, the stuff inside of stuff is really small. We can't see the momentum inside the spring, for example, when it's compressed. But we know it's there. So why pretend we can't, because we can't see it, we don't know it's there? Just like if we compressed air, it's more atoms closer to each other, and the atoms are repelling each other. And so I get it. There's a bunch of compression where there's more contact between the atoms, and therefore there's more energy because they're elastic.
What happened with the kinetic energy? Well, kinetic energy has clearly increased.
Okay, so this is just to some extent you're saying this is just nonsense. Okay. We already know that in this case he's going to use a compressed spring. So he's talking about an explosion, but he's going to demonstrate a compressed spring. And so you know the explosion is coming from chemical energy. We can't see the compressions. We can't see the elasticity built into the chemistry. So when you look at a piece of dynamite, you can't see it, but you can understand it, okay? That these are chemical bonds that are going to break apart, and the springs inside the atoms are going to expand the pieces of the atom very quickly, and so there's going to be a great deal of energy released. And so you know, it'd be silly to say there was no energy in the system before and there's no energy in the system after. There's clearly is energy in the system, and clearly, again, when you compress the spring, you know it was energy, whether kinetic or whatever you want to call it, whatever, you know, first name you want to give it, momentum energy or kinetic energy, it was there. You're not ever creating anything called energy. You're only transferring movement from one object to some other object.
There was zero kinetic energy to start with. This one now has kinetic energy, and this one has kinetic energy.
So again, they both have momentum too. So again, what sense does this make? This isn't a rational way to describe the reality. To pretend that the kinetic energy, whatever that is, isn't just the same as the momentum energy. It's made out of mv. It's made out of the mass and its velocity in a direction. What sense would it be to say that, well, when I put the square on and the half in front of it, I don't know where it's going, and when I don't, I do? I mean, it's illogical. It's just pathetically nonsensical to pretend you can take the same mv just because you put exponents on it and you know, stuff that, you know, extra bits, that somehow you've changed the fundamental nature of the mv. The mass and the velocity's nature is not changed by any of these additions. So why pretend they're different things? If there is such a thing as kinetic energy, it has to be made out of momentum, because it's made out of the m and the v. Come on.
Energy. Where did that come from? Well, was
Jesus. All right, so we know the momentum came from the same thing, the visible momentum of the two objects moving. We know it came from the same exact chemical reaction. There's nothing, it's the same mass and velocity, the same motion. So how the hell can we sit there and say they have different origins, or pretend one of them has a special origin different from the other one's origin? It's just, you know, it's nonsense.
the chemical reaction of the explosion. Momentum, however, was conserved. The momentum really doesn't care about these explosions.
So he doesn't care about the explosions. I mean, of course, that's the MV. You've now taken a hidden MV, little tiny MVs inside of some chemistry, or in this case the spring, and you've allowed them to be transferred to other objects, and now you can see the energy that already was present. You can see the big spring expands because a little bunch of little springs expand, and when they do that, you're going to see stuff move.
All internal forces. So be very careful.
So this is the key line, okay? Be very, very careful. And it says never confuse momentum with energy. So this to me is the big, you probably don't, there's probably not a bigger physics statement I could pull out of the physics air made by physicists that isn't more wrong than this. I mean, this is wronger than the bad assignment of plus and minus on electrons and protons. This is so elemental to what physics is, and this is saying exactly the wrong thing. This is exactly backward to the reality. All right, I never confuse momentum with energy, when everything about energy is about masses and velocities. And even if you were to say we think kinetic energy is special, it's still made out of momentum. How could you ever have energy in the universe without having mass and velocity? I mean, even when they play games and say some particle doesn't have any mass, they say rest mass, okay, because they will give it a virtual mass when it's moving, because they know it does have momentum. Because momentum is energy. Momentum is the clearest, directest, straightest line. You can't get a much straighter line between two words than energy and momentum. The line is dead straight, and here he is saying exactly the opposite. I mean, to me, this just, what's the credulity here? How can this be credible physics when we know they're fake kinetic energy? I'm going to call it that, fake. We know it's made out of MV. It's made out of momentum. So how can you say momentum isn't energy when the kinetic energy thing, if that's energy, it has to be made out of momentum? So why are you playing the game? Why play this game that momentum isn't energy, but kinetic energy is energy, and it's made out of exactly the same thing that momentum's made out of? I mean, it's just too silly. It's obnoxious to logic and reasoning. It's just so illogical. And to have this as a cornerstone of your physics, we're going to play a game and pretend energy is something other than masses moving velocities? Oh, huge mistake.
Never confuse momentum with energy.
He said it. No, always do that. Always confuse the two, and you will succeed in understanding reality. Because it's a fact. It's just a dead fact, okay, that it's all about masses and velocities. It's all about momentum.
Energy can change or cannot change.
There we go. And energy can change or not change. It can increase or it can decrease. Remain the same kinetic energy. So he's saying it can increase, it can decrease, it can remain the same, it can do anything it wants, it can do anything our math equation says we want it to do whenever we want it to, and it just doesn't matter. When, of course, he has to concede, well, of course, it's all about masses and velocities. Yes, of course. Yes, it's about exactly the same thing momentum is. Momentum is explicitly exactly the same thing as anything we're going to call energy ever. So anytime we say something has energy, we're going to show you it has a mass and a velocity every single time.
Increase or decrease or remain the same kinetic energy. But if there are no external forces on...
So more playing games with these external force nonsense. It doesn't mean anything. It just basically is saying explosions happen in both directions. So if an atom expands, it can't expand in one direction. It has to expand in both. Blah, blah, blah. So any expansion has to bleed into both directions. And so that's all he's saying. There's a symmetry to releases of energy. So when you release energy from a stored condition, it releases, okay, symmetrically.
The system, momentum, is always conserved.
So let's understand. He's saying momentum is always conserved. The MV part has to be conserved. So isn't the game already over? Which one is a better representation of reality? So if the momentum has to be conserved, isn't that the one I should be paying attention to? Why would I pay any attention to this fake stuff that you can make up and destroy without, it meaning anything in the universe? I mean, how can it make any sense that, we conserve momentum, but we don't conserve energy? I mean, it's a nonsense. I mean, even Feynman wouldn't say that. He'd say the energy blocks, you've got to account for all the energy blocks. You can't not conserve energy.
And this is what I can show you.
So he's not going to show us, and he's not going to explain it, and he's not going to do any of that stuff. So he's not going to explain how a 10-ton train has less energy. A 10-ton train going 5 miles an hour has less energy, half as much energy, as a 5-ton train going 10 miles an hour. He's not going to show us how that's true.
I have a demonstration set up on this air track.
It's not going to show us how a bullet has 2,000 joules of energy. 1,000 atoms, one atom moving 1,000 miles an hour has 1,000 times more energy than 1,000 atoms moving 1 mile an hour. He's not going to show us those two mobs and show us how those two things don't have exactly the same capacity to knock down a door. Because they do. And you could imagine they would.
And we do it on an air track, so there is a minimum of friction. And we're going to push two cars together, and we hold them together with a spring. The spring is like the explosion, like the dynamite that can push these apart.
So again, the spring is obviously kind of saying to you, look, I'm doing this two-direction thing. So it's an explosion and now just in two directions, but it still has a symmetrical component in the sense the spring wishes to expand in any direction. It doesn't care whether you're allowed to go that way or you're allowed to go that way. It doesn't have a preference, all right, and it's going to be symmetrical. Now, it's not going to push up and it's not going to push down. It's not going to push in a lot of other directions, but the directions that it does have the stored force, the force is symmetrically oriented. And so it will be an explosion. It will have whatever it has in one direction, it'll have to have its opposite component in the other direction as a capacity. It has capacity in both directions.
So here is one car on the air track, then there is a spring, and there's another car. Let this mass be M1 and this mass be M2.
It is kind of funny. He doesn't use coiled springs. He uses belts of steel to bend, and so it's a different kind of spring, and even that isn't much. And, he doesn't do any lectures talking about the different kinds of ways you can store the energy in different materials that would be called elastic.
And this surface is nearly frictionless, and I hold them together with a string so that I can pull the spring in. So this spring is compressed. And the whole system is at rest. V equals 0.
So again, we know that we could push that energy in with in a known way. That is, we could lock down one of the blocks and we could have the one block fly in at a velocity and create the compression in the spring and then lock that compression. And we would know how much energy we stored, how much energy we put into the system. And that would make this experiment a little better, frankly. But whatever.
So there is potential energy in that spring. I take a burner and I burn away this thread. This is the situation before. Momentum before is 0. Total momentum afterwards would also be 0.
So again, total momentum, just saying the symmetry, there'll be the same amount of energy going that way as there is that way, so therefore there'll be 0. So he's just saying the pressure has to be conserved in the sense that the pressure will go in both directions. Now the trick is, if I do lock down M2, that is I make it very, very heavy, or I just stick it to the surface very, very well, then that's not going to happen, okay? The total momentum before and the total momentum after won't be the same, because I will in fact have all of the momentum go back out the way it came in. So we have every expectation that springs are relatively conservative. That is, they do a pretty good job of giving you back what you put in, depending on the spring, of course. And so, tennis balls are pretty bad. You think tennis balls are pretty elastic, but you only get 75% back. You lose 25% of the energy. It's a pretty big loss of the directionality. So what this again is just sort of a scatter argument. You're just saying that you want to have a system or an experiment where you scatter as little of the energy as possible and you keep it in the directions you wish to analyze. But it's just a fact. So, playing this game with their 0 initial energy doesn't say anything, because all I do is I tie this M2 down and I have the same 0 initial energy, and I'm going to have free energy. You're going to argue when I release it, because I'm going to have momentum in one direction. So it's not going to equal 0. So the whole thing is sort of, nonsense. To analyze it as if we don't know we put energy into the system when he knows he did, and he put a fixed amount of energy into the system, and he's going to get that energy back, and that's the real conservation. So frankly, this is just confusing a subject that should be very simple.
It's identical to what I did there. And so this object will fly in this direction, and this object will fly in that direction. And you already can tell what the ratio of the velocities will be, because you will see that v2 prime divided by...
So he's just inverting the two this is an inverse proportionality. So he's going to put, v2 on the top of one fraction, and he's going to put m2 on the bottom of the other fraction, and therefore they'll have an inverse relationship. So if the velocity goes up, the mass goes down. If the velocity goes down, the mass goes up. It's the same amount of total mv will go in both directions.
v1 prime, you see it right there.
But of course they won't. If m2 is massive enough and it doesn't yield, then m1 is going to take back all of the energy. It's going to take, as if it brought it in, it's going to take it back with it. So it's going to get all of the velocity and all of the momentum.
Equals m1 divided by m2. And so I will make some predictions about the speed of these two objects. The largest mass...
Well, I mean, predictions based on a pretty obvious inverse relationship. So it's big V with little m equals big M with little v. I mean, he's just going to say is whenever I make the velocity bigger, I have to make the mass smaller. Two things are, it's all about momentum. He's clearly pointing out it's all about momentum. Momentum is in control of this experiment. Kinetic energy isn't.
By the way, would get the smallest velocity. And the smallest mass would get the largest velocity, the largest speed.
And they're just inverse. You just pointed out they're inversely proportional. So there's no point in saying largest speed and this and this. You're going to say exactly the opposite condition will exist if I make the numbers 2 to 1 or 4 to 1 or whatever. I'll get exactly proportional relationships.
What you see in here are really speeds. We don't have the information on the direction anymore. How do we measure the speed? Well,
all right, so we're not going to bother with this part because it's really, he just talks about cutting a card and okay, I missed by a millimeter, it's not 10 centimeters. Then he talks about how the photo sensor works and who cares. So none of that's terribly interesting. And now wait, of course. Tacky.
0.4%. So
big butts. Anyway, all right. So I would predict that the times of the two carts.
I would predict that the times of these two cars will be the same to within roughly 5%. That would be
right. So he's saying it's going to be the same momentum on both sides of the experiment. And he's just pointing out that, yeah, some of these numbers are fudgy in terms of my timing device because I can't cut a card precisely enough and I don't know exactly how good the photo sensor is.
my prediction. So we're going to write down here the times and then we're going to measure.
So he erased his proportionality, and he'll put that back again later. So the inverse part, the part that's just telling you big V, little m, well then the others, then you have the big M, little v.
Measure them. So time 1 and time 2, and we will see whether these two numbers are the same within the uncertainty of our measurements.
So because they both have the same m's, they have to have the same v's, is the simple argument. You have to conserve the momentum. There's no place where you're going to lose a lot of the momentum or scatter the momentum, so the spring will work fairly reliably, everything will do their job fairly reliably, and it's sort of an outcome that's inevitable because you can't really undo anything about it because momentum is in control. And the fact is, the spring's going to push just as hard on both sides, and it's going to distribute the energy. As long as the object yields to the spring will push into it energy if it yields. If it doesn't yield, then it can't put the energy in, and it all reflects.
Here is the air track. Have to turn on the airflow. Oh, let me tell, for those of you,
Jump ahead of this too.
for the parents in my audience who haven't seen this one, this
just
is a
much
marvelous device. It is a track which is well constructed so that these cars fit beautifully on this V-shaped track. And then we blow air out of this track, which lifts these cars up so that they float. And
Right, and they float with what you can't be assured is a perfect angling. So the problem is it's extra energy pushing into the system, and as long as the carts stay perfectly horizontal, you're okay. But if the carts tip, then you're not okay, because now you've created an exhaust for the air to actually push the cart, up into gravity, essentially, and create a ramp. Yeah.
So we can move them in horizontal direction with extremely little friction. There is no metal touching metal.
Right, so you get rid of the friction, but you're creating another source of an imbalance that can be created where you'll have a source of extra energy.
The only friction you have is the air drag. That you can never avoid. When you go through the air with a car, there is wind, the same wind that you feel when you drive your bicycle. But it's very little. And
Parents don't drive their bicycle, but whatever.
that's why these experiments are done on these air tracks. These are not cheap, by the way, these air tracks. They're very expensive. Well, you pay $25,000 tuition, so you might as well get something for it, right? So I hope that these timers are on. They are. And now we have here one car. And notice how frictionless it goes when I touch it. Very nice. Almost frictionless. And here we have another one.
So it is a little weird that they do have different springs on them, it's supposed to weigh the same, blah, blah, blah. This one has the strip of clay, which is interesting. So we do see where the clay comes from. So the clay was used as a balance for the carts, to keep the carts from wobbling. And obviously in the other experiment, it was there as a blob. So it wasn't there to stop wobbling anymore. It was there to fuck with the experiment.
And they have equal mass to within 1 gram. And there is a spring between them. Some of you may be able to see it. And I'm going to attach now that string to hold them together. And so I put potential energy in the spring by pushing them together. And they're lined up now here. They have no momentum.
Right, so we know that there's plenty of momentum stored in the spring, and that it would be momentum that would compress the spring. So he applied a momentum to compress the spring. He could have applied it directly by just pushing something in at a velocity, just as gravity pushes you down and creates momentum into the ground. Because all that energy is weight. It's just you say something is a mass, okay? So it doesn't weigh anything as just a mass. And when you give it a velocity, now it weighs something. So it's only when something has a velocity can it weigh something. So I can make you weigh your weight, okay? I can make your mass reveal itself and show us your weight by just moving you at 9.8 meters per second into a spring on a scale. I could measure your weight this way. I can measure your mass this way by giving you a fixed velocity, and then I'll know exactly how much mass it is, because I'll know exactly how much total momentum it pushed into the spring with. So momentum always works. It's a great way of understanding the universe. It's just to understand that it's just about masses and velocities. This experiment demonstrates it clearly, and the entire subject of the kinetic energy is totally unuseful in any way of enlightening you on what took place. And it becomes more obvious when he has the different masses and velocities, because then it makes no sense. The whole idea of conservation is broken.
The timer is not on. Has to be reset. Thank you. And now both 0. Yeah, you sure? Okay. So now I'm going to burn off that wire. The momentum of each one of those cars will change. One will go in this direction, the other one in this direction. Kinetic energy will increase. That's the potential energy from the spring. But the momentum of...
So again, there's no possibility, okay, that you can increase the kinetic energy and somehow say that that increase isn't based on momentum. It's mv, okay? It's 1/2 mv squared. The half and the square have no reality. They're just extras. The mv you can't change. It's made out of momentum. You can't say there's no momentum, but there will be kinetic energy. It's just baby talk.
The system as a whole, after I burn the wire, will remain zero.
So again, it's just more nonsense about there's symmetry built into the universe, and therefore whatever circle I draw around a hunk of universe, inside that piece of universe there is symmetry. There is just as much this way as there is that way, blah blah blah.
Ready for this? Make me happy. What do you see? You're going to make me unhappy? I better walk around. I can't wait. 220. Oh, fantastic! Absolutely fantastic. 223, 219 milliseconds. That is well.
That card didn't bounce very well, and it does have a tendency to go this way, so that's not too good either.
All within the uncertainties.
He stopped it from moving. You can see it's still going.
What was the number?
Still going faster.
219?
Up, now it hit the other card. Oh, poo.
To thrive in the city, it takes ingenuity.
Oh, fuck that. I mean, really, come on. He can't do better than this little grab for money. I wonder what's going to happen when he's dead. I mean, it's, you know, sorry, he is old. Is his videos for the rest of time going to be owned by some corporation that's going to do this crap to them? You know, ads you can't even skip? Pretty tacky. Alright, so obviously, same times, same energy went both ways. And the important experiment now is going to do is the one with uneven masses, which is going to more clearly demonstrate how kinetic energy doesn't make any sense, because basically he's going to point out how the same momentum is going to be exchanged. I mean, you're going to do the same thing again. You're going to split the momentum between the two carts, and somehow you're going to end up with a lot less energy going one way than the other way.
219 milliseconds and 223 milliseconds. If I repeat the experiment and I make the string shorter, I will get different times. I can never predict the times, because if I make the spring...
Obviously you could predict them, so that's again just kind of cheating and saying, okay, I can't... Obviously you could make very regular strings. The strings were just loops. So you could just tie loops around any kind of, you know, symmetrical object, tie them the same circumference around an object. You could make them pretty reliably exactly the same distance when they're put across the two little notches. And so you could do these experiments where you put the same amount of spring compression in within 5% and see the results and calculate the exact amount of energy you got out. But unfortunately, they didn't do those experiments, right? These are the ones they don't do. The nice clinical, let's get to the real truth experiments.
More squeezed, then obviously I will have more potential energy. And so the speeds of the cars will be higher. But the times will be the same within the uncertainty of the measurements.
Well, the times can't be the same. So but what he's saying is same is he's saying that somehow there's going to be the same momentum going both ways. The momentum will be conserved.
So I can never predict the time. Now we're going to do an experiment whereby I'm going to make M2 twice the mass. M2 is 488 plus or minus 1 gram. Now that's going to be interesting, because now you really begin to test the conservation of momentum. The momentum before is 0. I burn the wire, momentum afterwards is also 0. But the velocities, oh, I erased this, v2 prime.
So again, this is just the inverse relationship. You increase the velocity, you have to decrease the amount of mass, you vice versa. The two are inversely related.
Divided by v1 prime equals m1 divided by m2. And so twice the mass will get half the speed.
So I could replay that again and again and again, and he's explaining why it has to be that way, because you have to conserve the momentum and the system is symmetrical. So the symmetry of the system requires there to be a symmetrical division of the energy. But again, I'd argue only in the case where both objects can move. If both objects can't absorb the energy, then one of them is going to get all of it.
So now you're going to see that one car will go twice as slow as the other. That's the only way that nature can conserve momentum.
So again, just pointing it out, the momentum conservation is the important thing. These systems have to conserve the momentum. So if he was drawing a lever, he'd say you have to conserve the momentum. If he was drawing a hydraulic system, he'd say you'd have to conserve the momentum. And if you do that with those systems, you will end up with nonsensical kinetic energy numbers. The gun has to conserve the momentum. You can't say the bullet has 2,000 of something and the gun has 2. You can't say the bullet has 1,000 times more of something, because your ratio, your statement is that you have to conserve the momentum. And the fact is that you do conserve the momentum, and you get an energy number that's just plain silly.
Nature has no choice. Nature can deal with kinetic energy one way or another.
So whatever that means. So nature can deal with kinetic energy one way or the other. What do people think this means as a statement? I mean, we can throw it away, we can find it, we can make it, we can destroy it. And they'll always show you the destroying experiments. They'll never show you the free energy experiments, because they know, gee, I would be making up garbage here. Right? So they're not going to show you the experiment where they put a gun, okay, inside of a gun. You know. They take the explosion from a bullet, the amount of dynamite, this much energy. And they put it between two guns, one gun put inside the other gun. And they let the explosion takes place and the two guns fly away. And they say that system has 4 joules of energy. There's 2 joules going that way and 2 joules going that way. And then do it with the 2 bullets and just a plain steel pipe, and just allow the bullets to take the energy. Well, now all of a sudden they're going to have 2,000 and 2,000, got 4,000 joules of energy. So somehow the same explosion is going to reveal 4,000 joules of energy, and in the other experiment I only got 4. 4 to 4,000. Somehow, well, if I'm using these experiments to measure how much energy the gunpowder has, what's your conclusion going to be? That you can't measure it with heavy objects? Or should I just keep going lighter and lighter and making more and more energy? So yeah, I make the bullets half as heavy, I'm going to create even more joules of energy. I mean, how can this make any sense to anybody who does logic and reasoning? How can you smash these puzzle pieces together and tell me they fit? This does not make sense. It does not make sense to say the power of the gunpowder is completely arbitrary. I make the bullets light enough, I can keep increasing the yield from the gunpowder. I can make the gunpowder produce more and more and more energy by just making the bullet lighter and lighter and lighter and lighter, and obligating it by his very own formula to go faster and faster and faster and faster. I mean, taken to the logical, taking the logical steps of expanding this simple experiment to lighter and lighter objects, you have to understand the same spring ends up making more and more energy. I compress the spring and I make the carts half as light. I'll create twice the velocities, and by the kinetic energy theory, I have twice as much energy in the system. I've made free energy merely by cutting the masses in half. And I cut the masses in half again, and I make even more free energy. Now I have 4 times the amount of total energy. It's the same spring compression. How can it be making 4 or 8 or 16 or 32 times more energy? How can it just keep making more and more free energy by me just making bullets lighter and lighter and lighter? Come on. I should not have to make this argument for 2 stinking years. This does not make sense. It doesn't work. It's not reasonable physics.
But it cannot finagle momentum.
So again, he's talking of, yes, of course, you have to conserve momentum. Conservation of momentum is the law. Energy cannot be created or destroyed. That's because you cannot create mass and you cannot create velocities out of nothing. They have to come from somewhere. The masses exist and the velocities have to come from somewhere. You have to take something else's velocity to have a velocity. You can't have it without you getting it from someplace.
Must give the more massive car half the speed than it gives the other car. And so we're going to redo this experiment now with a car here which is twice the mass. And this one...
It is weird too that he has to select these cars and they really never really quite add up right. So
is one's mass. So this is the 244 and the one on your right is the 488.
So this has a lot of, well anyway, see if we get a close-up of the cars.
So I have to bring them together again with a string. So I do the work now. I always do the work.
So again, we're back to, well, how does these carts having these weights make sense? So you'd have to say that this cart is much longer than this cart, okay, more than twice as long. And I suppose some of that can be revealed by just measuring the distance of the weight. The weight is almost the length of this cart, and it's sort of clear that this cart is much longer. So in this case, the cart are uneven in the sense that this one is not two of this one. This cart is less than one length of this cart, and you can sort of see it by the length of this, because clearly you have the weight, okay? This distance plus this distance is a lot longer than this distance of the weight. So that's why so they are the right weight. I'm just saying that clearly his carts have a lot of, there's a lot of weirdness going on. So this one these do have the clay strips on it. The big cart doesn't have the clay strips. So it's obvious reasons to say if they were cut to the same size that they couldn't have, this one couldn't weigh twice as much because it doesn't have twice as many weights on it and it doesn't have clay strips on it. So it obviously would need to have 4 clay strips on it. It doesn't. All right, anyway, it doesn't have any. But anyway, so in this case, this cart is obviously longer than twice the length of this cart.
Work here in 26100. I do the work. I squeeze these springs. I get paid for that.
So he's conceding it's work, and he's conceding the work must be momentum, because that's exactly how I would create the compression. I would just have something move into the spring with a momentum, and it'll create exactly the same compression. It's the compression of the spring is a standard. It's a standard amount of compression based on the distance, the amount of distance the spring is compressed. And so the ways you're going to acquire that compression is through momentum.
By the way, and that's potential energy that goes into the spring.
So again, it's more nonsense talk in the sense of calling it potential energy when it's the energy is in a state where it's not being released. So it's circularly trapped. You could call it trapped energy. Stored energy is good enough. But potential is in my opinion, playing games with words that really don't belong there. It's not potential energy. It's just stored energy.
There it is. Momentum is 0. Kinetic energy is 0.
Well, again, and you know that it's only those things because there's a hell of a lot of tension on this wire. This wire's not saying it's all 0, but whatever.
I have to 0 the timers. Oh, and I would like to make a prediction. I would like to see, we'll measure T1, and then we'll measure T2, and then we get a number, and we get a number.
So the idea is there's symmetry in the expansion of the spring. So the spring is going to want to expand symmetrically. And all you're really saying is if this side doesn't yield, then it can't do that, and all the energy has to go this way. It can't be half and half. And if it does yield, then it will be half and half. So if it does yield, half the energy goes this way, half the energy goes that way. Half the, whatever your MV numbers are going to be, you're going to have the same amount of total MV this way as you'll end up with this way. And it just has to, it's all or nothing. If it yields, you get half. If it doesn't yield, you get nothing. So it's either a complete reflection or the energy, because the object actually moved, it will move at the right velocity. So it either goes at a velocity, a mass and a velocity moves, or it doesn't. But that's it. There's no, it got a little bit of the energy. It either gets enough to acquire its mass velocity total, or it doesn't. So it's rather instantaneous. It's as soon as, right after, without very little. There's no point here where you could do any of their fake math where you measure distances and accelerations. The acceleration will be immediate. It won't hang around and wait to accelerate. So it's sort of like a Newton's cradle. They'll pretend they can do some sort of math and say this one decelerated at a certain rate and this one accelerated at a certain rate, and they can't measure any of that. Because basically what the energy does, the momentum, it goes right from one object right into the other object at the speed of sound in the material. So, and it's happening over the tiniest fraction of amount of distance that they're actually connected. And so, you know, it's all kind of just storytelling, that they have any mathematical way that they have any experimental way to actually apply their mathematical theory. And what they're actually applying is just the conservation of momentum. They're just taking the shortcut, which is reasonable. But they should concede that, yeah, conservation of momentum answers all these questions.
If we multiply this number by 2.00, then I would like to get this number within the uncertainties of the measurements. There is always an uncertainty in any measurement that you do. All right? Make sure that, are they timer 0? Okay, there we go.
So, clearly much slower, less, it's half the distance it's traveled that this one has traveled. This one obviously is going twice as fast. So, because this one yielded, it took half the energy, and this one yielded, it took half the energy. Half the momentum.
What do you
the
see?
Total energy stored in the spring. And if the big cart didn't move, then the little cart would be going twice as fast, because it would have to take all of the energy. But didn't move is an important word, right? Because there can be all kinds of movement that you don't see. So I really, this became clear to me, this idea, when somebody was dropping ball bearings. And they bounced much higher when he bounced them off of an anvil. So he had like a 100-pound anvil, a big one. And when he dropped them onto the anvil, they bounced higher than if he bounced them off just a table or some other surface. So yielding is an important word, because surfaces yield. If I have a 6-foot-long table and I drop a ball bearing on it, some of the energy is going to be distributed in a bunch of vibrations inside of the table. The table is going to move. Pieces of it are going to move. And they're going to take the energy with them. So I'm not going to get as high a bounce. But if I can make something that's really solid, and where none of the pieces agree to vibrate without the rest of them moving, then I'm going to conserve the energy. Because I'm not going to scatter it in unwanted directions.
406, 193. Whew! On the button!
So it really wasn't on the button, so, but whatever. It's close enough.
406 and 193. 0.406.
Alright, we've done this so many times, no point in playing all this again. So this part I have played before, blah, blah, blah. It's just clearly, okay, let's just finish him
Is
doing
that what you see?
the twice.
Yeah? And 0.193. Now I don't even need my calculator to multiply this by 2. I can even do that by heart. 9, 3.
So kind of funny that he doesn't really know what doing it by heart is. It says that you already have the answer. You don't have to calculate it. But anyway, so blah, 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 blah. Who cares? A little minor bullshit. All right, so we'll call that a video. I think I've made my points. And now I'll just draw a little bit and whatever. I'm just saying that he's clearly defending throughout the whole video. He's defending the conservation of momentum. It's got to be done. So if you're going to say you did a spring experiment or you did a lever experiment and you didn't conserve the momentum, you have to explain where the energy went. You have to show me that, yes, it's a big table and I made the table vibrate. Something where the energy went and why it went there. Okay, so you'd have to explain why. If you're going to say the half mass has twice as much inertia, you'll have to explain why it does, how it does. How is that even a possibility? All right, so the interesting part is that, okay, so I have something that won't move. Okay, it's nailed down. And then if I put something, you know, we have a compression of a spring, and we have the same compression of the spring for each experiment. All right, and I have a one mass here. All right, this can't be the same velocity as this. All right, so if I have a one mass and a one mass and the same compression of the spring, you kind of know that, well, the momentum has to be conserved. I have zero momentum here, so this one has to get twice the velocity. So this has to be going at a velocity rate that will be twice what these will end up with. So I could say these have one velocity, okay, in that direction, and this one has one velocity in this direction, and this will have to get two velocity here. So the energy that went in won't be the same energy that goes in one direction. It's obviously half the energy. And so everything in between is going to be obeying this rule according to Professor Lewin's video. So he just did the two mass over here. All right, and the one mass here. All right, and he got the result where both sides have to get half of the momentum. So this one has to go 1/2 the velocity, and this one goes the 1 velocity. Right? Pretty clear. And frankly, you're going to do that. You're going to do the splitting of half and half right up to this number. So I could have a mass that was 99 here. Okay, and because it does take the energy, it's going to take its percentage of it. It's going to have this insanely low velocity, but it's still going to take half, and this side is still just going to leave with 1 velocity. So this side will still take half the momentum, and this side will get the other half and go at some insanely small velocity. 0.99, right? Yeah. No, it'll be 0.09, right? Yeah, something like that. Very small velocity. So that to me is interesting, and then you can go through the Newton's cradle thing, okay, of whether you bang a heavy mass into a light mass and light masses into heavy masses, and the idea is obviously if you have a 2 mass and it has the velocity, there's going to be more momentum in whatever interaction you have with the small mass. Let's see. So, but I don't think it creates any clear paradox that there is here. I mean, this idea, there has to be a theory. So I'm just saying, I'm proposing, okay, that theoretically it's all or nothing. If you do yield, you yield giving away the complete amount of energy. You can't yield a partial amount. You can only yield the full amount. Now you can vibrate some of the energy away. You can do other things, but if you actually do move all of the atoms with a velocity, that their velocity will be the velocity necessary to absorb half the energy. Because whatever happens inside the spring, it does happen very fast. Okay, so it gets it up to speed right away. It doesn't accelerate to its speed. It basically just gets the speed or it doesn't get the speed. It either gets the velocity or it doesn't get the velocity. All the work the spring does is essentially in the very beginning, and everything else is just appearances. Okay, so let's just say the spring basically just pushes, in the first millisecond, and then as the spring's expanding, so it pushes, it gives the two things the necessary velocity, and the spring just pushes out as it pushes out at the same speed it's moving the thing at. So it's already moving in that direction at that speed. So it just looks like it's pushing, but it's really not pushing anymore. It pushes at the very beginning, the very first instant it does its pushing. And then the rest of it is just show. It's just filling in the gap. It's done pushing though. It's not pushing anymore. It's just following along at the same speed. So it pushes, it gets to go the speed, and then the spring just follows along at the same speed. Something like that. Alright, so that's probably enough for a video. See if anybody has anything anywhere close to on the subject thing to say or whatever, but yeah, whatever. Whatever. The participation level is just plain suck. Anyway, let's see what we got here. See if the comment retractor is around. Alright, so you're missing that momentum is a vector quantity. So it's just baby talk. There's absolutely, that's completely made up, Chris, okay? You have no source for that declaration. You have no reasoning for it. I've just explained how it's made out of MV. It's made, kinetic energy is made out of mass and velocity. How the fuck did it lose its vectorness? Moron. I mean retard. I mean fucking idiot. How can the MV lose its vectorness, its direction? It can't lose it anywhere. There's nowhere its vector can disappear to. The kinetic energy of a train running down a track is not confused. It knows exactly where it's going. It's a fucking vector, you fucking idiot. It's as much a vector as the momentum. You're just reciting their barf, okay? I mean, they're barfing and you ate it and now you're re-barfing it. This is gurgitation. This isn't reasoning. There's absolutely no reasoning between calling one a vector and one a scalar except to rationalize their mathematical bullshit. They want you to believe you can minus momentums and that somehow kinetic energy is a fairy princess. Oh, you people are pathetic. Where is this kinetic energy? Okay. For example, what are you talking about? You don't have some other comment here. For example, a set of dominoes. If we were to push one to start the chain, people say it is KE, but really it's the same force being transferred over because of momentum. I've just made it as clear as you can make it. There's absolutely no rational way to say KE can have properties that momentum doesn't have because it's made out of momentum. I imagine it's the same idea as Newton's cradle. I don't even know what that even, whatever. Newton's cradle is great, except it doesn't work with uneven masses, and that's the whole thing. If it did, then all this kinetic energy theory would go out the window because everybody would clearly understand you have to conserve the momentum, so who the fuck cares about whatever this crap kinetic energy shit is? Can't mean anything. The dominoes have more PE. So this is potential energy nonsense. So again, just play games with words. This subject is not about potential versus kinetic, potential versus active. This isn't about stored energy versus active energy. I think even morons like you could figure out that you have to conserve the energy, so it really just doesn't matter. We know it's an amount of energy, period, the end. Whether it's stored or whether it's active, yes, those are properties it can have, but I can't make more active energy unless I stored it somewhere first. I can't get voltage out of a battery if there's no voltage in the fucking battery. You have to put the energy in before you can get the energy out. I mean, this is just too, I'm sorry, you're a fucking idiot to be just spouting this crap. I already just dissected the fucking video. I pointed out these facts, and here you are just barfing this crap over again as if that makes any fucking sense. I just pointed out how it makes no fucking sense for you to say your energy, your kinetic energy is made out of something other than fucking momentum. Before the fall over than after they have fallen. The dominoes have more PE. So this is just more baby talk. Okay, they. I see. The same energy you start with, you finish with the same energy. I don't really think it's. I don't think it's useful to make comparisons to dominoes falling, because obviously a domino can fall because you hit it with a nuclear bomb or because you barely blew on it. So the fact is, the energy needed to initiate the fall can be infinitesimally small. So it's really not the subject. All right. The wave. Oh, God, I might block you just for that. Falling travels the same pretty constant speed. There's a lot of sound output and a lot of potential energy loss. So again, more baby talk about potential energy. And obviously each domino is generating its energy from gravity. So the real energy you've stored is gravitational potential energy. So yeah, it's not a great analogy. You saw where he burned the thing, it's a string, but whatever, holding the cards together, question mark. I'm going to block you. Yeah, fuck you. Duh, I saw it. God damn it. What a fucking asshole. They started with zero momentum. I just pointed out how obviously there isn't zero momentum in the system. So if I had done it ahead of time and I actually smashed a cart into the spring and you saw the spring compressed by the cart smashing and then I put the spring on it, you wouldn't say, oh, there's zero energy in the system. You fuck. Alright, start with zero momentum, and after burning they moved in opposite directions, and I talked about the symmetry of explosions, retard, and the total momentum was zero. So again, you can say it was zero, and it's not zero. The thing going this way has real momentum. I already made these points. I can't, okay, I'm going to block you, because I've just made these goddamn points, and here you are reciting the same obnoxious crap again? After I've already said it in the video, I explicitly pointed it out in the goddamn video, and here you are puking this crap at me? I just pointed out to you, you fucking lying sack of shit, that if I don't allow the goddamn object to move, okay, then all of the energy goes this way. And it's all free energy then, isn't it? Because the system started with zero, okay? I have the damn thing nailed to the ground. It can't fucking move. I bang it, I compress the spring the same exact way, the string, blah, blah, blah. This object cannot move. This object can move. What happens then? I started with zero momentum and now I have 600 million momentums going this way. I made free momentum. That's going to be your fucking theory, you idiot? Because there's not going to be any minus momentum, you jackass. I already made this goddamn point in the video. Twice I made it in the goddamn video. Now I made it a third fucking time. Because what, you're too fucking stupid to pay any fucking attention? So fuck you. You're going to be blocked. Alright. You so blah 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 blah. The KE was zero before and positive after. Alright, well, whatever. I'm just blocking you. Fuck you. You're just too fucking stupid. I mean, I can't, there's no point in making videos if you're going to pay zero attention to things pointed out 3 times in the video. Okay, your silly goddamn nonsense that there's zero momentum and I made zero momentum afterwards. There's something, a fucking train, a 10-ton train going 5 miles an hour this way, and there's a fucking 5-ton train going 10 miles an hour that way, and you're going to say there's zero fucking momentum? Fuck you till goddamn dead. You're too stupid to have a conversation with. How the fuck can you think that's zero momentum? It's just, there's just no hope. These people are just hopeful. Again, your people are belligerently stupid. You really think it makes sense to have a conversation and then sit there and say, there's zero energy in the system, and because I sent a 10-ton train going that way and a 5-ton train going that way, now there's still zero energy in the system. You really think that's science? That's as dumb as Professor Lewin holding up his fucking briefcase and then saying, I'm not doing any work. It's so fucking stupid. That's science? Fuck you. That's so stupid. God damn it. Getting better now. Yeah. The nicotine to the rescue. Takes the edge off having to deal with such morons. I mean, really, there's just no point in making arguments, right? Because every point I made in the argument, they're just ignored. Will any of you complete shit for brains admit that kinetic energy, the theory, 1/2 mv squared, is made out of mv? And there'd be no way that the 1/2 mv squared could have properties other than exactly the ones the momentum already has? I mean, it can't undo the properties of the mass or the velocity, right? Those properties can't disappear. So whatever kinetic energy has, whatever properties the momentum has, fuck, the kinetic energy's got to have them. Can't lose the properties. See, they're just still gutless. If they really believed in this kinetic energy, then they'd want to say kinetic energy has to be conserved. They'd really want to, because obviously that's what Galileo, Descartes, and Newton all thought. And that's what they sort of built their physics around, was this conservation principle. Now, for them, it was simple, because yes, obviously all you're conserving is the mv. You're just conserving the quantity of motion. The addition, the multiplication of the mass times the velocity. The quantity of motion, they called it. And so, yeah, it was really simple. But if you really had any, if your science had any integrity, you say you have to conserve kinetic energy. But you can't say it, because you know that all I do is make the bullets lighter and lighter, and I'm making more and more kinetic energy. I'm making an explosion have more BTUs of heat potential. I'm making it have more power by merely making the objects it's pushing smaller. I mean, there's just no consistency in what you are arguing for. It doesn't make any sense at all. That I can destroy energy by merely making things heavier, and I can make free energy by making them lighter. It makes no frickin' sense. I mean, you can see it. It's basically saying half the mass. So you've reduced the mass by a half, and you've squared the velocity. Created this insane disproportion when you're basically pointing out that momentum says it's a reciprocal. If you have a big V and a small m, and then I have in the next case I'm going to have a big mass, a big M, I have to have a small v. That they just keep spouting the same crap. F equals ma squared. it's 9.8 meters per second whatever that means. I went 60 miles per hour in my car. All right, 2-minute warning, I suppose, is appropriate. I mean, really, to make the counter argument, they really have to draw something, right? I mean, they have to draw Professor Lewin's example, and they have to show me what it does when the object doesn't move, and how the same rules apply somehow when they don't. I have the same closed system. All I did was nail this one to the system. It's not going to take half the energy. It's going to give back more in that direction. Or else, you have to concede. I guess the thing to do would be do that experiment. See, it's just impossible to imagine that. All right, so let me draw that part. Because the whole system moving is a possibility. I mean, obviously you could move the whole Earth and claim, oh, I gotta keep remembering the mouse is over here. Yes. All right. So we're stuck at this bottom piece, so I'll just redraw that. Alright. So the simple point would be, is if I have an immovable object and I bounce a ball into it, right? I know I'm going to get most of it back. So let's say it is a good spring. It's not a tennis ball. I'm throwing it into a spring and it bounces back. And I'm going to get whatever velocity I put in, I'm going to get back. And then we know that if this object yields, that is, it moves in this direction, we know I'm not going to get back that velocity, right? There's no chance. If I throw the tennis ball and the damn thing moves, this side moves, this bounce back is going to be less. So the bounce back is here. We know that if this side moves, that the bounce back is going to be here. It's going to be less. I'm not going to get the same bounce back. All right? So all of a sudden I've changed how much energy is coming back this way. All right, and I'm changing how much energy is going this way in a sense. So let's just tie this to the whole system. So let's just say this is tied to the whole system. All right. So now how can I have the argument that this piece, when it's connected to the system, okay, it bounces back well, and when this yields, it doesn't bounce back as far? How could I have the same amount of energy? Right, on both sides. I can't have the same amount because I clearly have less coming out here. So, and the argument is the more this side yields, the less this side bounces back. So how can that really make any sense, right? So if I make this as small as the thing bouncing in, then I get the same amount going this way as I get this way. But it doesn't matter whether it's twice as much. I'm supposed to get the same amount going both ways. And it's supposed to be the same amount of pressure going in each time. I'm just saying it creates a paradox. It's the same spring compression. How can it create different amounts of energy? Simple enough argument. So if the argument would have to be that somehow when it moves the whole system, it has more energy than when it's inside the system. It has less energy. The compression of the spring is somehow less. Sorry, I can't make sense of that. I can't sit there and say there's some rule that fits this circumstance and this circumstance, because the two circumstances create a different outcome. There has to be a different amount of energy going in both directions. The explosion somehow has to be a different amount of explosive. It has to be much less explosive here than it was here, because I'm clearly getting my half is less over here, so I can't be giving this one half. Yeah. It's right in their face. Okay, well, these are just, I'm sorry, you can go ahead and say words, but I mean, they're words. I'm not, go ahead and say some of this stuff. I'm just saying it's not what we're looking for. We're looking for directed arguments at specific points, not just some ambiguous "they're idiots." I say that plenty. Don't need the commenters to add that part. So, don't know why you're testing. I haven't blocked you yet. Yet. I mean, really, you're a Tesla fan. What is it about Tesla? I mean, you really do think there's free energy, right? Is that your thing? That you really think the universe has, and it's not already free enough, right? I mean, it's pretty free. You know, we can steal it all over the place, pretty easy. We can stick our little wheel in the water and steal the energy. So it's not like it's that hard to steal energy, you know, from places. But you want it to be even freer somehow. Like, you know, like there's some really big river somewhere that you can steal lots and lots of energy from, but the river doesn't do anything harmful. I mean, obviously there's tons of geothermal, right? But the problem is you can't really collect it without digging up a bunch of radiation and a bunch of acid that's going to rot your pipes. You know, so it's not really easy to get to because it's dirty, okay? And so nuclear, you know, lots of energy there, but the problem is it makes really toxic dirt, you know. So that's the only thing in the way of us having lots of free energy is just the fact that, well, you know, and the solar energy is really free in a lot of ways to collect as heat. But that's always a problem too, you know, because then you're heating the earth and that's not good. But the fact is you can absorb it, so you'd be cooling the earth in a sense. So if you absorbed it and used it, but there's just not enough of it, right? You only got 1,000 watts per square meter, so it's not enough wattage to satisfy your needs. But do you really think there is some undiscovered energy thingy that you're going to grab energy from, some flow of energy somewhere that you're going to magically discover and be able to stick your water wheel in it? I mean, all you can do is figure out how to tap the ones we know about more cleaner. I mean, so they're trying the fusion thing, but the fusion thing is, again, you know, it's kind of a silly idea in the sense that we know that the atoms, the nuclei of the atoms are really difficult to duplicate their creation environment. It takes an insane amount of pressure, and you can't make the insane amount of pressure without using an insane amount of energy. And the whole thing, trying to contain it, would be, you know, you're just asking for an explosion that'll, you know, blow up your electrical plant. I mean, all the practical limitations. I mean, the very fact that they waste money investing in it, in a sense, is kind of, you know, almost silly, because you're just saying the infinitesimally small area that you're going to make all of this heat in is so small, and how are you going to get all of that heat into water or something else to move a turbine? How are you going to convert the heat into useful energy? Even that's going to be a very that's like you'd be better off trying to tap lightning, you know, trying to figure out a way to store lightning in flywheels or something, you know, because there's a hell of a lot of electricity in lightning. And, you know, if we could collect the lightning, that would be to me, that's mechanically a doable thing. And, you know, we just need a really cool transformer, you know, and a really, you know, clever one. Well, you need a battery is what you need. Because you have to store it before you can use it. It'd be interesting to see if they made a system with enough wire in it. You know, you could almost argue that you could do the conversion through some resistive manner, you know, where you have the lightning hit at a remote location and you put all of that lightning through a whole bunch of conductors that do some work and reduce the voltage ultimately to something more usable. I don't know. To me, it's a much better theory. You know, it's a better engineering project than fusion. Would be to try to capture lightning. So you're not going to answer my question, though. Okay. You just came here to say test. Okay, gotcha. I mean, you could just say, yes, I am a free energy nut. You know, I'm not going to block you for it, but, you know, it will explain why you're, say the crap you say. I didn't hear it. I just came back. Well, there's no point in typing crap into my comments section and then running away. Yeah, I got the hear thing. I can figure that stuff out. But anyway, well, I already did I'm not going to do it a second time for you, so forget it. I'm just basically I'm narrowing you down into some kind of free energy nut that thinks energy is just, there's some place where we could just find a huge amount of energy. We could just stick our little water wheel in it and there's going to get all kinds of free energy. I mean, that's what Tesla believed. Tesla believed there was a bunch of energy flying all over the place and big streams of energy all over the place. He had a silly, in my opinion, understanding of the fact that you can't make pressure without using pressure. I mean, you can't hold the pressure unless you make a system for holding the pressure. I mean, you have to. Let's see. There's no yin without the yang kind of thing. It's really hard to do that. So I'm just saying that all we can do is tap active streams of energy. And the active streams have sort of been pointed out. And you can create active streams by breaking atoms. You can create active streams in all kinds of different ways of releasing energy. But collecting it is the tricky part, right? So, because it ends up being too dirty. I mean, if it was as simple as just you drill a hole in the ground, it's warm down there, you just pull the heat out, it's just not that simple. It ends up being too dirty. Too expensive to deal with the dirt. I think, like I said, Tesla was really good at taking stuff other people had already talked about and done and turning it into something. So I'd say, yeah, I mean, you gotta applaud. The guy made a radio controlled boat, back in whatever it was. I don't know. I'm trying to think of the dates to get those right. I mean, 1910 or something. I don't know. No, it was later than that. Well, anyway, so that was a great thing, and the funny part is that in that context he was given a simple job by the rich people that financed him, J.P. Morgan and the rest of them, and he could have done that simple job of just creating a communication system using Morse code, turning the radio signal on and off. And instead, he was so obsessed with transferring energy from one place to another that he lost sight of the ball he was supposed to be, inventing. But look, you can read his patents. His patents cover almost anything. You know what I'm saying? It's like I think he's just kind of a manipulator, in the sense that he wrote up patents that basically patented drinking water or something. I mean, they were so generic and unspecific. And again, it was based on work that other people had already converted into a reality. So let's understand that in Europe they had already done the Niagara Fall thing. Okay, they had already taken a waterfall, converted the energy through a generator into electricity, transmitted it, okay, in two phase, I think, to a carnival, and then recreated a waterfall out of so they'd already done it, okay, before we thought we invented it. So it is kind of bullshit. So again, you're saying the AC motor, he invented one version of the AC motor. Let's understand, his is a phased motor, okay? It's a 3-phase motor, okay, with no brushes. It's different than a regular AC motor, which is really a pulse DC motor. Pulse DC motors work. And again, in what context? I mean, every one of the things I could say, I could go through all of Edison's inventions. You have to give him credit for the light bulb, because that was, an insane amount of energy he put into making durable filaments. And so it was somebody else's thought, somebody else's idea, somebody else had already got it to glow. And Edison made it cheap, okay? And that's just a fact. He figured out how to make one that was practical. So those are different arguments, right? The theoretical arguments versus the, make it work thing. And so the sound recorder, you got to give Edison the credit there. He figured out, okay, that you record sound mechanically on devices, and then you could remake the sound by just remaking the mechanical process that created it. So huge up to Edison's microphones. I mean, you can go through all this stuff, and you're just saying, by comparison to Tesla, come on, get real. And, everything that Tesla advanced are all things they would have invented 3 days after Tesla did. Okay, I mean, they were so inevitable. But you got to argue that some of the stuff these other people figured out is pretty advanced stuff by comparison. Now, I don't know about the movie projection thing with Edison, because that started with just flipping cards, images. And the idea I think part of the problem was creating film that was fast enough, to take images sequentially. But a lot of that was just turning something that was a theoretical idea that you could possibly do this, and then converting it into again, a practical one. And that's why Edison ended up with a bunch of patents, and that's why there's a Hollywood, because all the cheaters wanted to get away from Edison's patents, and so they made movies as far away as they could from where Edison could sue them. I mean, the real history is kind of funny. Okay, I'm going to block you if you say shit like that. That's just disgusting. Show me one idea that Edison stole from Tesla. That is just such a fucking lie. Tesla stole all his ideas, so you're really close to getting blocked. You have to defend that with evidence. What idea of Tesla's did Edison steal? Preposterous lie. Tesla was a bit of a lazy shit, okay? And he kind of thought every time he invented something while he worked for Edison, he thought he should get paid $1 million. Like he was a partner in the business. He wasn't an employee, right? So he comes here to America. He gets the privilege of working for Thomas Edison, a huge, gigantic, plus. and he basically squanders it, okay, because he's so full of himself that he thinks he should own half the company. Oh, fuck. I mean, you people really are nuts. Tesla's tower was insanely stupid. It didn't do anything but shoot lightning bolts into the ground. I mean, it's just so fucking dumb. It's a Vendegraph machine. What do you think is fucking ahead of its time? He made a vending graft machine is all he did. A gigantic one that wasted whatever. He pissed away all his money. He had to make actual electrical plants just to fuel his experiments that were supposed to be creating free energy. So his free energy was the most expensive energy ever. Not only did you have to build all this hardware, but you had to fuel it with even more energy than he ever produced. Oh, God, you people are just so stupid. Yeah, it didn't work because it was theoretical garbage. Everybody who knew anything, this is where he lost all his credibility. This is why he couldn't get employed, okay, in his later years, is because everybody knew he was a fucking fruitcake. And that he would waste millions of dollars on absolute nonsense, and he would never concede that it doesn't work. He would not concede that things didn't work. He just kept saying, I have to do this and I have to do that. He kept promising his laser gun that was going to end war, right? He was going to end war by making a gun that, evaporated human beings. Oh, great. That'll really help. Look, okay, what you think now has become less and less meaningful to me because you just keep talking absolute shit. So instead of explaining what Edison stole from Tesla, you're saying something like, I think, yes, Edison made all his money selling batteries. Edison made lots of money and put it back in his company and then lost it again and then got it back again and then lost it again. Every invention, gave him more money to spend on trying to do other inventions. So he made a ton of money on the talking machine. He made a ton of money on the movies. And the whole the electricity thing got messed up because he ended up competing with another company, and both companies basically went bankrupt. So that was the problem there. Is they were both way underselling. The selling price was way below the actual production cost of what they were producing. And so both companies took a huge hit trying to outdo each other. Trying to, they both were trying to, sneak in with a lower bid price. And neither company could make any money because neither company could make a bid that was reasonable. Edison made and lost 25 fortunes. One year he's up, next year he's down. 1 year he's up, next year he's down. He did employ Tesla. Even the way you say that, Tesla was given a great privilege. Again, it was a privilege to work for Edison. That was pretty high status. You're working for Thomas Edison. And, from him basically just getting a note from an Edison employee in Europe who basically said, this Tesla guy is good, So, I think you can use him. And he did. But again, Tesla thought, because he did some good engineering on I think it was all about a ship that, the lighting system on the ship had completely failed. And so the electrical system. And so Tesla, spent a couple of months fixing everything and getting it all to work. And he basically figured he was, pay me $1 million. He was always looking for a big giant paycheck for everything. And he didn't understand what it was to work for another man, I guess. And so then he ended up digging ditches. I mean, it's just a fact. I mean, nobody else wanted him. So after he left Edison, he dug ditches. Yeah, well, I can understand the never marrying part, but yeah, he did live a monk's life, if you want to call it that. But again, he liked fancy dressing and dinner parties and all that crap. He wasted an awful lot of time just being a celebrity. So, that part I have to take some points off for, because he sounds like the devoted science type. But he really isn't the perspiration type, and so he can talk about how Edison smelled and all that kind of crap. But the fact is that if you just go by how much thinking Edison had to do, and how much creative work, I mean, how much time he devoted to working rather than sailing boats, you have to give an awful lot of credit. But whatever, you can. I don't care that you think Tesla was a great scientist, and that's fine. But I'm just saying that all I see is a lot of hype, and it all revolves around a bunch of mysticism about Tesla having secret technologies, and Tesla being on some sort of right track. And the fact is, he was on a really wrong track. I mean, the very idea of thinking you could transmit electricity through the earth or through the atmosphere, you've got to know that it ain't going to work. That's a shitty conductor. It's a really shitty conductor, and you're going to lose a lot of energy through those shitty conductors. We know that, even back then they knew you had to use copper wire. You had to use good conductors. You use shitty conductors, you were going to get you're going to lose an awful lot of electricity. So, I mean, what's the point of... It's such a non-starter to think I'm going to transmit real electricity through the shittiest conductor possible. I'll watch what you said earlier and reply tonight. Yes, that's fine. I don't think it requires much of a reply, frankly. I'm just saying that you're sort of just giving yourself away to me, personally. Okay, as somebody who's a hero worshipping hype botherer. It's all hype. Tesla was a lot of hype. Again, his motor wasn't even applied by Westinghouse. Westinghouse just, he wanted the patent, but he wasn't using the motor design. So it wasn't like it was an industry standard and all of that kind of crap. Because it had to be re-engineered. That's another thing that's never in the story, is that there's always somebody else who has to make it into a practical working device. And the fact is that everybody was going to two-phase, and so what good is a three-phase motor, if you get my drift? Westinghouse needed a two-phase motor that worked. He didn't need a three-phase motor, because he was basically committed to two-phase transmission. I mean, watch one of the Kathy Loves History and with Science or whatever the hell those videos are. She does a whole thing on Tesla. And it gets to some of it, but it doesn't really get to all of it, because frankly, a big part of what Tesla did was, again, this showmanship shit. He went to world's fairs and made sparks and electricity and, got himself famous that way. But he got himself unfamous every time he was interviewed. He talked like a lunatic and, frankly, lost all of that credibility. He kept promising things he never delivered. That was another part of it. He just kept saying, in another year I'm going to have this thing ready and it's going to be working. And people don't like being promised and then never delivered. Again, it's not about him disagreeing, so I'll just block you, okay? Yeah, I mean, if you're going to lie. Everybody could see why I blocked him. I blocked him because he's just going to regurgitate the same crap I just debunked 3 times. 3 times I explained how it doesn't work. 3 times I explained in 3 different ways how it doesn't work. And he just kept saying it works. You can't do that. You have to make a counter argument that explains why it works. I mean, I have talked about vectors and scalars hundreds of times on this channel. There's just no excuse for somebody to tell me kinetic energy is a scalar. It doesn't mean anything. In what way is the energy of a 10-ton train going down the track, how is the kinetic energy in any way a scalar? And how is the kinetic energy in any way different than the mass and the velocity, the momentum? How does it have less of a vector? How is it less in one fucking direction? How can you play this moronic game and tell me it's some sort of different thing? The energy of the train is going up when it's not. It's obviously not going up. I'd say you're talking shit. Do you realize you can measure things? And there's no measurement. Show me the train, the 10-ton train going 5 miles an hour down the track. Show me any measurement of energy going up or sideways or some other direction than the direction of the chain. Show me how any of the energy of the train, when it hits the wall, has anything to do with anything other than going one way. Show me. Or shut the fuck up. Just idiotic. Measure it in different ways. How? All we have are measuring tools, rulers, scales. You're telling me that my molecular weight isn't in the downward direction from gravity, that gravity is clearly in one direction? It's not a scalar of any kind. It's not kinetic energy. It's not going in any direction. It's going straight down. Fuck you. It's absolute bullshit. So again, you're just talking their shit. I mean, I'm just saying, what's the point? You're going to just keep reciting absolute nonsense to me. I've proven it's already nonsense. Energy has no direction. It's retarded. It has a fucking velocity. The velocity is in one direction, you fucking idiot. How can you say it doesn't have a direction? The velocity has a direction. Yeah, how is it hard for you to understand? Dungungalis. Okay, energy doesn't have... Okay, just keep saying it. All right, so fuck off. I mean, it's just... There's no point. You're not going to make a reasoned argument. It's absolute bullshit. Fuck off. I just can't believe how many people are just... They do this. They believe a complete fairy tale, and they just keep doing it. Look, it's not a coward. It's a waste of time. You're obviously impervious to logical argument. You're telling me that the energy of a fucking train isn't in one direction. You're telling me that somehow we can't measure it, we can't see it, we don't know exactly how much it has by its motion in one single fucking direction. And you're saying somehow the energy isn't in one single fucking direction. It's a fucking idiotic statement. Fuck off. I just don't get it. I just don't get people. I can't think of any way energy could possibly ever be except the fact that it has to be going somewhere. Every little bit of energy in the universe is going in a direction. It can't possibly do anything else. It can't be energy if it's not moving in a direction. It's just shit. Alright, well, we'll call it a video because clearly no one's going to say anything reasonable on the subject. Oh, just the power of religion. You don't think the individual elements are heated. So when something's hot, you don't think the heat is transmitted in basically straight line vectors by the individual atoms that are agitated. You think it's just some general thing? You don't think the individual atoms are actually doing the moving, the vibrating, and that they are all vibrating in specific directions? I called it scatter, okay? Yeah, it's getting scattered. So it's like photons scattered or anything else. The photons are still going in one direction. They have an individual momentum in one direction. They travel billions of light years through space in a straight line in one direction. I mean, it's not an issue. The individual objects that have energy are always moving in a velocity in one way. All right, well, we can say you can fuck off. Gee, that's good. You know, they're words that have meaning. You're saying that mv squared, 1/2 mv squared, isn't momentum. You're saying it's not made out of momentum. It's clearly made out of momentum. So how could the momentum have a vector quantity and the thing that you are making out of that somehow loses its vector quantity? Somehow the vector quantity disappears. The mass and velocity all of a sudden isn't the mass and the velocity anymore, because you put a half and a square on the velocity. Somehow we lost the direction of the mass and the velocity. Somehow the direction disappeared. Yeah, it's a ludicrously silly thing to say, okay, or to defend or to argue. Obviously, these words are just contrivances. They don't mean anything. They don't have any connection to reality. There's no such thing as a scalar energy. It's just pathetic. It's just contrived to fix their broken math. Like I said, their math is terrible. Doesn't get right answers. Work is not force times distance. Ay. Just momentum. Momentum is force. Clearly Newton thought so. And force is energy. Force is pressure. And force is weight. All you can do is create a weight. When things interact, all that happens is weights interact. So two things with different weights, that is masses and velocities, when they interact, all that happens is now the weights are compared and you have an outcome, and you have to conserve the weight. You'll never dissect that into being incorrect. That's how the universe works. Things just compare their weight. Alright, so I guess we'll call it a day. Another unpleasant day, but whatever. It's just part of the fun. Ugh. So again, if you want to comment, just understand you have to make a reasoned argument, and the reasoned argument should come with some sort of evidence where something I said is incorrect and you can show me somebody saying it correctly. So I played the Professor Lewin video. It has all the basic elements in it. You have to conserve the momentum. My argument is, how can you possibly conserve the momentum and not conserve whatever the magical kinetic energy is? Because frankly, it's made out of the same thing. It's made out of mass and velocity. And your silly little 1/2 and your square don't change the fundamental nature of the mass and the velocity. So, well, whatever. Just keep being religious kooks, I guess, is all I can say. If that's what you must be, if you can't do any better than that, if you can't function at a higher level than that, not much I can do about it. Except to argue you should be able to do better than this. A lot better. should be able to source your theory. So just link me to the video showing it taking 4 times the fuel to go twice as fast. Link me to that video and you have won the argument. Not much to ask, really.